All right, hey everyone. My name's Jared Parsons. I'm the C# compiler dev lead as well as a member of the C# language design team. And we're here today to talk about let's design a language feature. And what we want to do in this session is kind of pull back the curtain a little bit and show you kind of how the language design process works. How do we start from a problem and an idea and get through all the twists and turns to a shipping feature that we deliver as a part of the .NET and C# releases. And what we're going to be doing in this session is we're going to be using an example of a feature we shipped in C# 11 to kind of take you through that process. And that is file local types. Now, all ideas start with a problem. In this particular case, the problem came from our source generators teams. Now, for those of you who are unfamiliar, source generators are a way that the library authors can plug into the compilation process. They can look at the code you're writing and use it to generate code to augment your application. They can add new functionality. They can add optimizations by moving stuff that used to be done at runtime into the compile time part of the process. And we're shipping a lot of generators with .NET 7. We have like the JSON generator, the library interop generator, and like what we're going to be looking at here today is the regex generator. Now, what the regex generator does is normally when you use a regular expression in .NET, at runtime, that expression has to be parsed. They have to generate all the code to do the matching at runtime. That can impact things like startup. It can limit your optimization opportunities. But now in .NET 7, we have the ability to, at compile time, do all of that work. And you can see here that I have this nice little partial method called getEmailRegex. And I have this attribute generateRegex, which tells the regex generator, hey, here's a regex that I want you to process at compile time. And we can do a nice little go to definition here. And we can look at what this generator is doing. It's taking that regex, it's processing it, and it's generating all this beautiful code here, nicely commented, that's actually processing that regex. And it did that all at compile time instead of at runtime. Significant performance wins for our applications. But the generator authors came to us because they found a bit of a problem with this approach. Because in order to do a lot of their generation, they have to generate these helper types, like you'll see here, this derivation of regex, getEmailRegex0. And they said, this is a bit of a problem. We really want these types to be implementation details of our generators. We don't want users depending on them because this is something we want to evolve over time to continue making these scenarios better. But unfortunately, it's a part of the compilation and users can see it. Worse off is that when users are typing, IntelliSense actually shows it to them. It starts leading them down the path, telling them, hey, this is a type that you should use. Look at all these cool members. Take dependencies on them. And this is something they worried would inhibit their ability to evolve these generators in the future. And also, there's another problem. What happens if the user defines the exact same name type that they want to generate in their code? Well, that means that their generated code stops working. And in order to solve this problem, they have to complicate their generation process. They have to start scanning the compilation, looking for any types of that name, and making sure they don't have conflicts. And overall, they felt like that this made the generator scenario a bit more fragile, a bit more incomplete. And they were looking for ways to solve it. But they also had an idea. They came to us and said, listen, why don't you let us write private in front of these top-level types? And the effect we would have there is make that type local to this file. It doesn't conflict with types and other files and other people can't see it. And this is where kind of the language design process starts. We have a problem. And we have an idea for a solution. And it fits in with some of the big themes that we're shipping in the current version of .NET and C#. Now, you may have, at this point, be asking yourself, did I come to the right presentation? The kind of promise of this presentation was it's going to talk to us about all the problems you hit in the language design process. But it's just one word. This is just one word and one scenario. How hard could this really be to design? Well, first off, let's talk about that word, because one of the things that we focus on a lot in language design is syntax. And this is a new type of syntax that we have to look at. And one of the first questions we start asking ourselves is this word going to stand the test of time? For example, right now, the idea is just how can we make types local to a file, but a logical way you could extend this feature in the future is making it apply to members, methods, and properties, and making them local to a file. And private's not going to work if we did that, because private already has meaning in those scenarios. So that's just not going to work. The next thing we talked about is, what if we just take two existing modifiers, slam them together, and let's create a new one. And let's use private internal. And this may seem silly, but this is something we've done before. A few releases ago, we introduced private protected to express a new form of accessibility in C#, and it was a very successful feature. But it is a bit wordy. It doesn't really ring the scenario we're trying to get here. It doesn't really scream this is local to a file. So the next thing we talked about is maybe we just use modify private. We say, hey, private was a good idea, but let's give it a little more meaning by saying file private. And this is going to resonate with customer. This reads really well, and people are going to kind of get an intuitive understanding of this by looking at it. It's also a bit wordy, though. It is using two words where we felt like one word might be enough. And so eventually we kind of said, let's just use file. File is nice, it's descriptive, it's simple, and it's going to extend to other scenarios in the future should we want it to. And after a lot of discussion, this is where we came out with. This resonated the most with the language design team, the generator authors, as well as the various community members we talked to. And I've made this process a little bit silly, talking about the ways we deal with words, but the look and feel of C# is incredibly important. And we spend a lot of time talking about it, rat-holing, and going back and forth on the ideas. And we spend a significant amount of time on even little tiny problems like this. But the next thing we do, and we did in this case, is we said, hey, have any other languages done this before? Because if other languages have solved this problem, we can look to them for inspiration. We can see what went well with their implementation. How do customers use this feature in their ecosystem, and what can we learn from it to make our feature better? And when we looked around, we found lots of examples of other languages that do this. For example, F# has the concept of signature and implementation files. Very similar to like header files and C files in C++. But they have this really nice property. Only things that exist in the signature file are visible to other parts of the program. If you have a type that is only in an implementation file, it is limited to that file. And that is almost exactly what we're trying to build here. It has a bit more ceremony involved, but it has the basic properties we're going for. And this is a very successful feature in F#. It's used in lots of programs to wild success. Next, we looked at like Golang. Golang has a similar concept called package level visibility. Their mechanism is a bit different. Uppercase type names are visible outside the package. Lowercase type names only visible within the package. It's simple, but it is very effective, and it is highly used by the Go community. And these are not the only two languages we found this in. In fact, when we looked at other languages, pretty much every language we looked at had this type of capability. And this made us feel really good about this feature. It made us feel that we were going to be using a feature we're designing a feature that was not just usable by our source generator community. It was going to be something that was going to be generally usable by the C# developers. And so we felt really good at this point. We felt like we were on the right track and going the right direction here. So we took a step back and said, okay, before we get further into the design process, one of the things we want to do is establish the core properties of this features. What are the things that the experiences we are trying to deliver when we get to the end game here? And this is really important because sometimes you can get very deep in the weeds in language design, very deep in the spec, and it really helps to have these properties established that you can come back to and say, okay, this is the problem we're really trying to solve. How do we apply it to the current thing we're doing? And the core properties we had here is that if you have a type or a member marked with file, we want to make sure that, first off, you don't have to think about any other name conflicts in other files. What you're writing is what you get, and you can just simplify your world to this file. Also, this type cannot be observed outside of this file. I don't have to worry about people taking dependencies on it. I don't have to worry about any kind of weird conflicts. It is just right here. And lastly, what we're doing should not be observable by other languages. I mean, if we go through all the work of actually doing this in C#, but then F# can see all these types, it devalues the feature just a little bit. So with that in mind, the next thing we often do in language design is we say, hey, can we generalize this? Yes, we have a problem, we have a solution, and it looks like it's going to solve it. But is there a bigger problem we can solve here? Can we tweak this idea just a little bit and get a lot more bang for our buck when we do this feature? And there are two ways we looked at generalizing this feature. The first one was we said, hey, what if we also said, let's make types local to a namespace. Let's have this idea where a type is only visible to the namespace it's declared in. And when we looked around the kind of the .NET ecosystem and even like the C# compiler codebase, we found a lot of evidence that this would be a valuable feature for customers. To the point that we got pretty far in this design, but eventually we kind of stepped back and we said, yes, this is valuable. It seems like this would add a lot of good to the language. But it isn't actually necessary for us to ship .NET 7. And we do have a finite amount of resources for innovation in a given version of .NET. So we kind of put this one on the back burner. We said, this is a good idea. It's going to have value. But let's come back to it later, maybe in a new version of .NET. What we spend a lot of time on, though, and what we're going to talk about here, is whether or not we should let file apply to methods and properties. Now, intuitively, this does probably seem valuable. Like if I want to make a file local, a type local to a file, maybe I want to make a member local to a file. But there's a big gap between saying you want something and figuring out how to make that a reality. Like, what do we do in the compiler to make that enforcement real? And the first thing we thought about was maybe we just make file an access modifier. In the same way you have public and private protected, let's just make file a new modifier. Unfortunately, that has a lot of problems. First off, you have to go and change the IL specification for .NET to recognize the bit pattern for file. And then you have to go to all of the languages in .NET and make sure they recognize it. We have to go to F# and we have to say, hey, we have this new access modifier and we really need you to recognize it. And lastly, you have to go and update a ton of libraries. Like, there are a lot of libraries and code that look at metadata in libraries. So you have to change reflection. You have to change like any kind of metadata reader. And ultimately, this is an enormous cost to the ecosystem. And while it would work, and this is a valid way to do it, the cost is just out of proportion with the benefit that we would get from this. But we weren't done. We had another idea up our sleeves. What if we just took those methods and we emitted them with an unspeakable name? So an unspeakable name is a technique where when we emit to metadata, we just put funny little characters, usually less than and greater than signs, in the name. And that is a tried and true way for compilers to say, we want to hide this member from other compilers. This does not have the ecosystem cost associated with it. All the compilers recognize this pattern, and it would give us a way to hide these members from other languages without boiling the ocean. And C# does this a lot today. For example, if you use anonymous types, we emit them with this like unspeakable name where we have that less than and greater than sign as a key to ignore this particular type. Same with anonymous delegates that we generate. And even if you used a record before, part of the with process of records is we have to clone the original record before applying the new property. And that clone member is emitted with an unspeakable name because we don't want people using it. We want that to be an implementation detail of the compiler. And we could apply the exact same logic to file members too. If you said file void create, we could emit it with an unspeakable name. That would make it invisible to other languages. That would make it local to the file and really kind of achieve those goals we were going for here. Unfortunately, we found out that when we dug into this, that this has a number of side effects that are really unfortunate because a lot of features out there depend on the name you emit from members matching the name that the developer wrote in code. For example, interface hookup depends on name matching. If you're doing any form of reflection, like data binding, the developer needs to know the name that they wrote is the name that is in IL. And even C# features like dynamic depend on the names matching. And so while this would work, we could implement a like coherent feature here, it would massively subvert user expectations and break other scenarios. And we decided that that was not a good path for us to go down. And this kind of ended our exploration of using file on members and properties. We had a couple of ideas on how we could make it work, but we decided the cost was just not in proportion with the benefits of providing it. And so the final design we came up with this feature was we were going to give the developers the ability to annotate their types with file, and those are just going to be very local or private to the file they're declared in. And at this point, you might be saying to yourself, like, isn't that where you started? Didn't language design just go in like a big circle here and spend about like a couple of weeks doing it? And largely that's true. Modulo changing private to file, we ended up basically in the same place we started. But this wasn't wasted time. Along the way, we looked at other languages. We gained confidence that this is a general purpose feature that people are going to benefit from. We explored new features that we could do in the future in the form of namespace local types, as well as we charted a path forward for how we could extend this in the future to apply to members. Yes, we ultimately decided the cost wasn't there this time, but it could be the cost dynamics could change in the future. So while we did end up where we started, we have a better understanding of kind of what we're shipping. And we should always do this. We should be pushing the boundaries in design and trying to generalize. Sometimes it works, and sometimes we find a much bigger set of scenarios that we can tackle. But sometimes we end up largely where we started, and that's okay, as long as we kind of get this enhanced understanding as a part of that. But we're not done yet. As I said earlier, we have to find a way to kind of make this work. It's great to say that this type is local to this file, but how do we make that a reality? And as we talked about before, naming is the key here. We have to find a way when we emit this type into metadata that it has a name which is local to the type. And this name has to have a couple of properties. It needs to be unique per file, it needs to be hidden from other languages, and it needs to be the same between builds. If I build my code 10 different times, I need to get the same name every time. That's just a general property of compilers that you have to have. But it does mean we can't do anything cute, like saying that the name is just GUID.new GUID, which would meet the other two properties very easily. Now, when we think about kind of a solution for what are we going to name these types, a couple of the parts of the name are very easy. We need to include the namespace the type is declared in, as well as the actual name of the type. But we need to create a segment that makes it unique to that file. That little part right here. We need to figure out what that is going to be. And we talked about a couple of ideas for this. Firstly, we said, why don't we just make that the file path? After all, that's the whole point here, is to make it unique to the file, and the file paths are unique. Well, unfortunately, file paths have a couple of properties with them that are bad for us. One, they have an unbounded character set. Every file system defines what is legal for them. And many of those identifiers and characters in file paths are not legal as names and metadata. Also, paths can be arbitrarily long, to the point where it would kind of exceed the limits we have for identifiers in IL. And so we kind of discarded that as a solution. Then we talked about, well, why don't we just use the file name? We could force that to be unique, right? Well, that also didn't really work, and we had to kind of discard that as a solution because file names can be duplicated. But then we kind of stepped back and we thought, and we said, okay, every time you compile, files are passed to the compiler in the same order. So instead of using the path of the file, why don't we just use the index to where it was passed to the compiler? So as you can see here as an example, when we compile this simple program, we have 3 files, application, data, and container. Container is the 3rd file, so it has index 2, and we can just use that as that unique little segment there. And that works great. That actually solves all of our problems that we talked about earlier. We now have names that are local, unique to the file, and we have a way to implement this feature. But at this point in time, we did something we do with every feature, which is we involved the rest of kind of the C# IDE team. This is the team that is building kind of the Visual Studio and VS Code experience for C#. And we involve them because when we ship a feature in C#, we don't just think about kind of the language in the compiler. We think about the ecosystem of features that make up that developer experience, because we want these features to pop everywhere that you can use them. And they pointed out a flaw in what we had done here. They said, hey guys, we have this really awesome feature. It's called edit and continue. And you know what you can do with edit and continue? You can add and delete files from a program. So that customer there, they could just say, hey, why don't I just delete data.cs? That in turn is going to change the order of files passed, change their index. That type name is now going to flip to have a different number in it, and that's going to result in a ton of root edits. And this is a big problem, because edit and continue is a super valuable feature for our customers. And we just inadvertently made a design which basically made edit and continue extremely hard to get right. But the benefit of involving more voices here is they came to us and they said, hey, what other ideas did you all consider? Let's talk it through. Maybe we can help you out here. And we walked them through the process we'd gone through, the ideas we discarded. And they said, hey, file paths were actually a good idea, but why don't you just put them through a checksum first? Once you put them through a checksum, it'll be unique on one side, unique on the other. Also, it'll have a fixed character set and a fixed length. And that solves all the problems you all originally had with file paths. And they were right. It was a fantastic suggestion. It ended up being what we shipped. We now take the file paths, we pass them through a SHA-256, and use the resultant IL. Now, that name is super unreadable compared to the ones that we were talking about before. But at the same time, it doesn't matter. This is an implementation detail of the compiler. What matters is we now have a mechanism to implement file local types. And with that, we essentially have the solution that we were going for. And now we can kind of see that solution in action. So if we go back to this original example where the generator author said, hey, we want to use private, you can see that we have all these errors here because of the duplicate type names and such. Well, we can now just flip this over to file. And you can see immediately the errors go away because there's no longer a duplicate type problem. This type is specific to this file. It is completely isolated, and the generators can think only about this file when they are writing their code. Even better, when we flip over here, you can immediately see the error squiggles change because this class no longer conflicts with the one that the generator was producing. And as a result, we have an error up here because there's no member instance on this type. Now it's even more fun is we go up here, if we start typing like we did before, notice IntelliSense is not offering me to use get email regex because it is specific to the other file. It is not available here, and as a result, IntelliSense is hiding it. But it's not like we hide it all the time. If we go to places where it's legal, we can see IntelliSense is happily suggesting it to me. It's showing me it's there for me to use. And so now we have kind of solved this source generator problem. We have made this overall scenario a lot tighter, a lot more reliable, and we've also provided a feature that customers can just use generally in their C# code. All right. And so thanks so much for being a part of this session. So I think now we're going to flip it over to some Q&A questions.